So hi, here we are again. Now we are going to solve, okay, for this two exercise 1, 2, 3. Okay, we'll be quick. The first exercise, it says that we have 1. It is to analyze the convergency of this series 2 square plus 1 upon 3 square minus 1 upon 4 square. How to analyze the convergence of this series? See, first we have to know what is the series directly. So this is 1, 1, 1, 1. So 1. It's okay. Upon, this is when n is equal to 1, this is 1. To 2, 2. Directly you can understand this is n. Okay? Square, it's always there. Now, what about the sign? When this is odd, 1, this is positive. 3, positive. 4, negative. So when this is odd, is negative. When this is even, this is positive. So it will be minus 1 to the power n plus 1. Okay? So then how to find the convergence of this series? So apply. This is a oscillating, or how can I say, this is a alternative series. So apply Leibniz. Okay, first analyze whether this guy is decreasing or increasing. Just analyze for module of un. Okay, 1 upon n square. Just here we can just notice that un, okay, u1. What is u1? u1, okay, suppose just we can directly just put here for 1, n equal to 1, it will be 1 upon 1. This will be greater, will be lower. This 1 upon 1 will be greater than what? Than the second term. Okay, what's the second term? 1 upon 2 square. It is 1 upon 4. This 1 upon 4 will be greater than the term that is coming after him, 1 upon 9. This will be greater than 1 upon 16 and so on. So by this logic, we can say that this is a decreasing series. Okay, decreasing series. Okay, this way. Okay, this way. Secondly, the limit of this guy must be 0 to this to be convergent. Must be different of 0 to this to be divergent. Okay, we are just analyzing whether it's convergent or divergent. Okay, we don't care about this one. Okay, we just want to calculate, then we will just resume whether it's convergent or divergent. This goes to 0. So when I put here all this expression, what will I get? un square. Okay, limit of this, when this guy is infinite, it will be 1 upon infinite square. This will be 0. So it means that this is convergent by Leibniz test. Okay, and it's done just like this. Let's go for the second. The second say the second in this exercise. Okay, it is just to show if this guy, whether this guy is convergent or divergent. Even babes can solve this one. See, I'm playing. See, for this guy you can apply L, okay, limit comparison test. Okay, limit comparison test. The first thing is just un will be root of n square plus 1. Then what else you have to solve for? After this, we have just to play a bit with this to find what is bn. Now it will be root n. Pick up the greater exponent here, just factorize, take common n square, 1 upon n square. Okay, then this guy and this guy, we're going to be divided. Then this go down, n square minus 1 upon 2, 1 plus 1 upon n square. What you get here, you get 1 upon n, and here it will be 3 by 2, okay, 3 by 2, and here 1 plus 1 n square. Okay, so here bn will be 1 upon n 3 by 2. Okay, by p series, okay, p is equal to 3 by 2 greater than 1. It is convergent. So if bn is convergent, the last thing that we have to do is just to calculate the limit when n goes to infinite of un upon bn. This limit, what will it be? It will be the limit when n goes to infinite of 1 upon 1 plus 1 upon n square. Put here infinite, you'll get what? 1 plus 1 upon infinite square. This will be 0. Okay, this will be equal to 1. So if this limit of un upon bn is a number, it's a finite number, non-zero finite number, so we can say that un is convergent as bn. Okay, this is convergent as bn. It's okay, done. Let's go for another one. What is the next? This one, this guy. So here we have n goes 1, and this is n to n plus 1, the power 1. Here directly, if you just see, this guy is just showing up himself. Just by seeing, you can understand that this guy can be solved directly by applying root test, because this is root. Just put here root, this limit will be easy. Okay, yeah, by root test. So what does say root test? Limit when n goes to infinite. Okay, when I have un, okay, un 1 upon n is equal to l. So this is limit l greater than 1, l lower than 1, this converge, the series converge. L greater than 1, series diverge. L equal to 1, test fail. Okay, so just calculate for this one. N goes to infinite, put it there, it will be n to n plus 1, n raised to n upon 1. This one will go out with this, u and then n to n plus 1, n goes to infinite. So this and this limit will be only 2n upon 2n, n and n, this will be 1 upon 2. So here l is greater than, lower than 1. So by root test, it is convergent. Okay. Okay, let us go for this one. Okay, here they ask us, we are going to do these ones, okay, in the last, but let us solve for this one. Here they ask us to find the sum, the result of this, guys. So it is like here we have infinite, and n goes to from 1 upon 4 all by n. Okay, I will just find the sum. Okay, and okay, from 1, this will be 4n, then what else, minus 3, and here 4n plus 1. Okay, if it is to find the sum, I mean it is the result of this guy, to find the result for this guy, what we have to do here, that's the point, just to find the sum of this guy. So the first thing you have to understand is that this one, okay, this one is what? The sum of this one. This is a 1 upon this one. This is a geometric series, okay, is a geometric geometric series with ratio. What is the ratio? Ratio R is equal to 1/4. That is less than 1. So this guy, the sum, the whole sum, 1/4 to the power n, the whole sum will be A1 upon 1 minus R. What is A1? Put here 1. You get 1/4. And here you get 1 minus 1/4. Just solve for this guy. But you get 4 minus 3. It will be 1/3. Just solve this one. This will be 1/3. Okay, this is the result for this one. Now, how about the second one? This is from 1 and goes from 1 to infinite. Then I have this one. So this one, just check here. Okay, this one, it is the same. Okay, it is the same as I wrote something like this. See here, it is 4. So if I put here this guy negative and this guy positive here, I will get this one, n plus 1 upon 4n minus 3 times 4n plus 1 minus n 4n minus 3. Okay, and here 4n minus 3 and also minus 3 and 4n plus 1. See, just transform this guy in partial sum. Okay, partial sum. Then what is the next thing? The next thing you have to do is just to simplify. See, if you simplify this one, 4 minus 3 and this one and this, you will see that this guy will be the same from 1. This will be what? Will be 1 upon 4 n minus 3 minus, okay, 1 upon 4n plus 1. Okay, yeah, so this all, now that I have this one, okay, this expression in partial sum, okay, in partial sum, what will I do? I'll do this one. This will be 1 upon 4n minus 3 minus 1 upon 4n plus 1. Just solve. Okay, suppose when n is equal to 1, put here 1, put here 1, 1, you'll be 1, and you get minus, put here 1, you get 5, plus, now when n is equal to 2, put here 2 and put here 2. If you put here 2, you get 8. 8 minus 3, 5. 1 upon 5. If you put here 2, you get 8. 8 plus 1, 9. You get minus 1 upon 9. Plus, do the same for 3. You get 1. Put here 3, it will be 12. 12 minus 3, 9. Then, minus, if you put here 3, you get 13. And so on. Just look at this. Okay? This guy, if I sum, this guy will be cancelled out with this and this with this. I will just take the terms that are remaining. This is 1 and minus 113. Minus 113 will be repeating over and over. This is this expression only. So this will be 1 upon 4n plus 1. It means that if I sum all these terms, this guy will be equal to this one. Now what I have to do, I have to find what is the limit, okay, when n goes to infinite for this summation. This will be 1 minus 1 upon 4n plus 1. Put here infinite, this will be 1 minus 1 upon 4 times infinite minus 1. This will be all 0. This will be only 1. To find this sum, okay, now that we know what is this, okay, we know this one, the result of this partial sum, we know this, and we know that the result also of this guy will be 1. If I sum all the expression of this guy, will be equal to 1. And if I sum all the expression here, will be equal to 1/3. So here I just substitute. This will be 1/3 plus 1. Just add them, you'll get 3, 4, you'll be 4 by 3. Okay, 4 by 3, and you are done. Okay, this is what they ask you to do. Okay, let me see if there is another exercise I can do. Okay, this two I'll do for the next section so that I cannot overload you guys.